Alrighty, gang. Villains, thieves, friends, new enemies. I'm excited to battle. Hopefully, don't have to go fisticuffs with nobody here. But thank you for joining me. Nice little post-lunch discussion, round table, fireside chat, whatever we're doing these days. We are going to discuss software. I love software, if you haven't figured that out. But I love infrastructure and everything in between, which makes me a weirdo, I guess. But today we're going to talk about these software factories that I mentioned yesterday, and we're actually going to kind of spin one up. So let's see if that works. Yesterday I did talk about a little automation, why you should be doing it. If you're not yet already, again, it's 2019.
I installed Ansible.
Good.
Last night.
Excellent. If you need some help, holler at me.
I will do it.
Happy to help you. I got a bunch of Ansible workshops I can send your way too. But we learned, automation, super key, super easy. You'll love it. That's exciting, pretty cool. I'm sure a bunch of y'all went down on Docker and did some Kubernetes fun stuff as well. And we're all doing DevOps now, right? Like DevOps is cool, DevOps is hot, and this is not Florida, is it? We're just going to forward it to this side. There we go. I'm going to have no control of what's going on. All right. Do it with no code, they said. Get out of PowerPoint, they said. It's cool, it's easy, it's great, they said. It is. It's great. I like it. But if you ain't got the internet, kind of boned.
This is the dark and full terrace part, right?
This is the dark and full terrace part. Like, this is running on a Kubernetes cluster, which is why I'm like I'm trying to enjoy and dog food the services and things that I'm working so hard to put together, right? Because as someone, I work lower end, and I like to see some of the cool stuff that's built up on it. This is what we talked about yesterday. Hey, it is working now. That's great. Someone mentioned the Mugatu reference, so I definitely had to put this in. This is actually normally in a lot of my other presentations. But it is super hot. Everyone's doing it, and it is super duper cool, right? We're going the wrong way. It's probably better if I use this thing. Not as cool as these kids, right? Maybe. I don't know though. Let's think about it. Their attire's actually not that cool. There's some software in there, as you know. They've got a couple tracking sensors in their shoulders, and as they enter and leave school, it tracks them. And you're thinking, darn. Well, I'll just give my jacket to a buddy and tell him to put it in his backpack, and then I'll just still skip school and, smoke cigarettes with my friends. Well, they also use facial recognition technology as you enter to make sure that you're not pulling something mischievous like that too. So software is doing some really cool things these days, right? And software is having some interesting effects as far as our security goes. Software is hot, data is hot, it is more valuable than oil and gold, is from what I hear. We've been under a cyber war for a long time now, especially on the public sector. If anyone isn't familiar with how the armed forces and branches of the government work with contractors, the Army, the Navy, the Air Force, they don't really do a lot of computer stuff. All right? They contract out to different companies. DoD CIO's initiative, it's done by this company called Cloud One, I think, or Level One. It's a silly name. But they do that for a lot of reasons. Indemnity is one of the big reasons. Right? That's how Accenture can hire offshore developers, and whenever they poop the bed, hey, they underbid everybody, so we're just going to try again on the next procurement cycle. Either way, if the whole Snowden thing didn't get you interested in how Booz Allen Hamilton and Boeing and General Dynamics and General Atomics and all these other folk work, just check it out. It is an interesting ecosystem. It's weird to be in it. Now, software, otherwise, the development of software itself There we go. A little too far though. I'm here to pick on software too, right? So I like JavaScript. I do a lot of JavaScript myself. Why is this thing not fitting? Now, the underpinnings of our software is laid on matchsticks. Actually, I misquoted the statistic yesterday, but if we just play with the wrong packages here and there, we can do some pretty good damage to it, right? This thing sucks.
Damage done.
All right, well.
Have you tried turning it off and back on again?
NPM up there.
Click.
I have tried that, actually. Well, I'm going to try this. Which one's the real access point? In Suites or Murfreesboro? I know that was going to happen.
Murphy, sir.
Knew that was going to happen. Nobody telling the truth. Go to random IP. Let's log in. I agree to whatever monitoring you're about to do. And I can get to Google. Great. All right, let's see if this works. Maybe the pod is failing on the Kubernetes cluster, who knows? That would be great. All right, much faster. This looks much better. All right, so our house is built on matchsticks that is ready to burn down. And again, as much as I like to poke fun at JavaScript, let's also poke fun at somebody else that's pretty equally important in the enterprise environment, and that is Java. Any Java developers out here? Do you know what Bouncy Castle is?
I haven't done development in Java in a while.
Okay. Bouncy Castle is one of the cryptography libraries in Java. It's a very core, crucial cryptography library. It's been vulnerable. There have been numerous vulnerable versions of it out there in the ecosystem for decades. For over a decade. Decades is too much. And there's still vulnerable versions downloaded to this day. This is from a buddy of mine who works at Nexus, or Sonatype rather. They run the Maven repository, so if you download Java components, it's likely coming from the Maven repository. It's like the node npm repo of Java. But a lot of that's probably from Jenkins, and we'll see that later today. So what I'm saying is that, as anyone in the security industry knows, it's an awful show, and we're just pretending it all just kind of works together. My name is Ken Moini, and I am here to tell you that your baby's ugly, basically. You can see my shit code on GitHub. We'll actually see that here in a minute. We'll shit posts on the Twitter. If it looks like a polar bear, you're in the right place. I don't. I work for a company called Fear Software. This is a value-added reseller. We work in the public sector, so we actually get to go on site to some of those contractors I named earlier, and I get to teach them this stuff. We get hands-on keyboards, and we do Ansible workshops. We do all sorts of different things. And I put a lot of these things together for them, help them get started. There's, again, a little extra value. We don't just sell you the software. We want to make sure that it's not just shelfware and you're going to be upset with it 6 months later because you haven't got the road map set up. But either way, we do some cool stuff. Got a league of workshops on Ansible, on data science, on containers, on security, cyber threat hunting, secure software factory. We'll see in a little moment as well. But yesterday we talked a little bit about Kubernetes, right? The Kubernetes comes from a Greek word of shibtaten. Just a little fun fact, a little trivia. Ansible comes from Ender's Game. But either way, Kubernetes is that magical thing that's going to take your containers and it's going to run them across your enterprise, right? Great, we've solved all of our problems now. Well, what is a container? Just as a recap, it is a process. It is process isolation. But it's the smallest form of compute as far as you're concerned in this context. We get a couple things kind of misconstrued in this ecosystem a lot. Container images and container runtimes, or the binaries, right? So you've got Docker, which is the runtime. When you run Docker run, that is the runtime, actually acting on an image. Okay? There's a couple things to get discern between. There are a couple different runtimes. They're a little bit more open source, a little bit more community driven because Docker kind of went a little ways away. Different sort of image formats as well, different ways to build them. Some cool stuff in the ecosystem now, as you might have seen from that explosion timeline. Now you're going to get these container images from a repository. Yay, we're pulling things from where you've probably heard of Docker Hub, right? We're able to tag them, different names, and version them. So if you're used to Git, this is going to feel very familiar to you, all right? What is really cool, actually, I'll point out, is that say we deploy a new application, right? Like let's say front-end 2.0, and we realize, oh no, it doesn't work in this particular cluster that we deployed it to. That's great. We deployed everything with latest, but we know that 1.1 works. We're just going to redeploy to 1.1. That atomic versioning, that hashing between the changes of the file system is pretty cool. And it is just an overlay file system. It's basically a tarball is what it is, right? These are all like primitive technologies made easy to use. So containers run in pods. That's how you actually kind of address them in an ensemble. Now you can actually assign them IPs. You can put multiple pods or multiple containers in a pod. Traditionally, you want to run a single container in a pod because you're going to be scaling pods. You're not scaling containers in an orchestration framework, so you're scaling pods. Scaling multiple containers in a pod is very difficult, and it's the silly monolithic way of doing things, right? If your messaging queue is starting to fill up, you need to scale that. You don't need to scale your front end. If you got the containers all in one pod, you're scaling everything together. So, just a thought. Deployment sets, deployment configurations. There are different ways to deploy. Basically, you can take a verbose description in YAML, the same stuff that Ansible's written in, and you can deploy an ensemble of these pods and their configurations. Now, how do you address these pods? You've got services. This is just produced by DNS, okay? So if you don't know much about DNS, you should learn a little bit about DNS because DNS is going to be everywhere in a Kubernetes cluster, and it is going to be hell for you. Kubernetes natively only brings kubedns internally, which is this backend service. That allows you to name pods and address them between each other, right? So now what I'm able to do is invoke the front-end service from backend, and I literally just query the backend as an FQDN. So if I'm querying an API and I'm, say, use the Mailgun API to send out transactional emails, right? Cool. So that's api.mailgun.com/v1 blah, blah. No, your address is just backend / whatever your path is. Pretty cool stuff. Again, DNS, so get used to it. That's kind of where Kubernetes stops. This is where you start to think about your ingresses, all right? There are a couple different kinds of ingresses that you can have. Your Nginx ingress, you've got a couple other ones that I'm forgetting. I don't know, I just use the Nginx ingress. It's great. Actually, some people use virtualized big IP F5s. F5, wow, that was backwards. Scratch that, reverse it. But you can do a couple different things for your ingress north-south traffic. Now you separate your different projects into different namespaces, and that kind of keeps things and people and applications and systems where they're supposed to be. They can talk between each other, but traditionally they don't. All right, so we've got Kubernetes, right? And we're ready to rock and roll. Nope. Well, some of that networking actually is not really built into Kubernetes. A lot of the Kubernetes deployers will deploy like Flannel or Weave or Open vSwitch, right? So that's no problem. This is traditionally what people think of as Kubernetes to start off with. If you're running Kubernetes, you're going to be pulling in those images, right? So you're not going to be wanting to pull in from a hub on the internet every single time every single node deploys another pod. That sucks. So we're going to load it up one of our own. That's great. Otherwise, we need a little visibility because as soon as a pod dies, everything else with it dies traditionally, including logs. So if your pod is erroring out and it's just going into a crash loop, that's what it's called, a crash loop. It just operates, dies, operates and dies, operates and dies, and then stops. Kubernetes goes, okay, this isn't working out. I need some space. But if you don't have persistent metrics and logging, you can't really see what's going on very easily. We need to be able to manage the lifecycle. This is also kind of a little bit more built into Kubernetes over the last couple of versions. Application services, as you're starting to build out these platforms, of course you need something integrated, like a little glue that goes together, and of course a little click panel, POW, and then there's a bunch of other stuff that kind of goes into operational Kubernetes. Do Kubernetes the hard way. I implore you, do it. It's great. You learn so much, especially about public key infrastructure. Wow. I don't want to learn any more about PKI. But it is very important to know, and it kind of unveils all the things that it does and that you still need. You'll find a lot of these things here on this eye chart. Again, this thing's going to haunt you. If you're going to get into this ecosystem, this thing's going to haunt you. And it's updated pretty much every day. This thing's already out of date, so I'll tell you that much. The one thing that I will mention is, and I promised myself not to make this too salesy or whatever, because that's what I do during my day-to-day. I'm talking concepts. But we're going to talk a little bit about OpenShift, because that is what makes my life easy. Just like Ansible, right? I love Ansible for automation. That's what I use, and a lot of shell scripts. But OpenShift makes my life easy. You have your hand up?
Yeah, where's that diagram? Where's that from?
Oh, this is the Cloud Native Foundations. It's a big, like the Linux Foundation. It's a bunch of weird hokum and people in suit, glad-handing and patting each other on the back for supporting open source. But there's money behind it. They help drive innovation, so there's some good that comes of it. But the Cloud Native Foundation, this is their cloud native landscape. There are different sort of levels for being in this ecosystem. As you're going to bet, you probably got to pay money to be on here, right? So there's a little bit of a price to get your logo on here. But there is massive exposure, like your KubeCon and all sorts of fun stuff. So if you are developing a Kubernetes native application, this actually might be your trajectory. This is actually where we're going to be landing with our secure software factory. It is something that we're actually kind of getting going. It's pretty cool. We're already in the process of deploying our container as a certified Red Hat container, which is really exciting. So that just means that we're enabled to be deployed into FedRAMP locations like OROC. But either way, I'm babbling on. But this is really cool, and this literally changes day to day. There is a date on here nowhere because I scrubbed it out because I was really embarrassed last time somebody pointed out how old it was. But this thing really changes out very quickly. One I do really like is OpenShift because instead of doing this whole building of Kubernetes things, which really sucks, no two Kubernetes clusters are going to be the same, really. Yeah, you can template and deploy yourself, but I'm not going to make it the same way you're going to make a Kubernetes cluster. And I guarantee you that by the time that I do all the work to set it up and secure it, or whatever your organization does, a new version has come out, the APIs changed, there are a couple different manifests and custom resource definitions to make your life a new nightmare, right? So let's operationalize, let's offload that task, let's get Red Hat to do it. There's an open source version called OKD, or Origin Kubernetes Distribution. Yeah, wow, I nailed that one. It is the upstream version of OpenShift. So if you're looking at just you want to run Red Hat's OpenShift for free, OKD. Right now, if you're looking to run OpenShift 4, it would be Code Ready Containers. That's the new, they love changing names. I mean, that's how everybody's kept on their feet, right? They do a lot of security hardening, a lot of extra validation into the SE Linux context, which we'll get into in a moment, and a lot of other fun jazz. And it is pretty foundational in our secure software factory. But as I like to tell people, that I don't really care about OpenShift in itself. It is the platform of broken dreams. Like, I'd love to sell you a bunch of OpenShift, but without workloads go on there, you're going to be upset. And that's usually actually what happens with a bunch of people who jump into container workloads without figuring it out first. What's really important is not OpenShift. It's everything that you've got running on top of it, okay? It's this pipeline. It's Jenkins that's delivering your applications through your different namespaces, through its different processes. It's a centralization on your developer workflows. I've gone to organizations where they've had Bitbucket, Mercurial, SVN, and they use GitHub. Now, we're also working with organizations that have centralized around a specific one. Most times it's GitHub. Like, they get GitHub Enterprise with their ELA through Microsoft now, that they got, it just works out well for them. I can't fight it. I don't care. It's a good solution for them. But as soon as you centralize around repository management, you're going to get some cool stuff. A couple steps through here, important concepts to think of. Again, I don't want to get too salesy. I just ripped this out of my normal presentation slides. Automation everywhere, okay? If you're doing it in a secure context like a lot of our customers are, you're going to be dealing with different sort of benchmarks and STIGs. This is STIGs a lot. CIS is another benchmark that we're seeing a lot whenever you're deploying cloud workloads, right? Use automation to set that baseline security context. There's a project called Ansible Lockdown. It actually takes CIS and this is STIG benchmarks, and you can flip a bunch of switches, set whatever sort of level you want to scan at. It scans, it does an open cap STIG scan. And then it applies your actions if you want. And then it gives you another report to show you the difference in a cool color-coded chart. It's dope. Check it out. Now, software analysis, something like SonarQube, another open source project. What's cool about that is it does things like code smells, it does, type checking, all sorts of fun stuff, just to make sure that your developers aren't making like common errors, right? It's going to improve the baseline quality of your code. Software code analysis tools like Sonatypes, Nexus repository management. What's pretty cool about that is that, for instance, you want to find out what's really built in your Java application. You want to find out what's really built in your container. You want to find out what's really built in your Node application, because you don't trust your package JSON, right? Whatever the case may be, you throw your application at it, it proxies registries like NPM and Docker Hub and this, that, and the other. It lets you put policies around that and all sorts of lockdown and fun stuff. But it'll also produce you a BOM, a bill of materials, right? So it's actually going to produce a list of the dependencies and different components in your baked software, which is really cool. It also discovers licenses. We're going to, something about licenses, not to touch on it too much. Some licenses are kind of aggressive, like the AGPL license. A lot of organizations that I work with do not allow AGPL within their organization because that license mandates that whatever it touches is also open source. A lot of our customers like to consume open source, but they can't give out open source. They do, but in different, discrete ways. So that's something important. Maybe your organization doesn't want to support something like beerware. Okay, there's a beerware license.
Free as in,
Huh?
as in free.
Yeah, well, no, it is free. Free as in beer. But the beerware license says that if you meet me at a bar, you need to buy me a drink. It's not a bad license, right? Church of Latter-day Saints does not allow that license in their organization. Just a little fun fact for you. They do it with Sonatype. So they block like certain sort of licenses, and that's one of them. And we're seeing a lot more issues come up with licensing, especially in the open source community. We're seeing different open source projects kind of divest their licensing and all this other fun jazz. By the way, to kind of blow through this, you need to be able to scan your containers. They are basically just Linux systems in an overlay file system. you can stig and scan and act upon these sort of benchmarks with OpenSCAP. Ansible Enterprise is the one that makes it a little bit more operational. And then OAuth Zap is pretty cool. It lets you kind of brute force a couple things and go through just a bunch of, well-known exploits. And say you built like a PHP application and you want all your inputs like just thrown garbage and a little chaos engineering through it this way. It does some cool dynamic application state testing. All right, this is going to be weird. Let's order up one of these secure software factories, right? Oh shit. It's not scale now. All right. So I believe in making everything a little web app, because why not? Whenever you're deploying a lot of these things, and I'll go through a couple of them in a minute, you have a lot of very common configuration bits, and if you don't automate it, if you don't kind of inline it, humans will mess it up. I've gone through hours of troubleshooting just because someone has taken a bunch of manifests. These manifests, in fact, you can check out, say, Nexus IQ server. So this is a deployment. You take one of these, maybe with a little persistent storage, a template, makes it available to your cluster. It does all this other fun stuff. Bunch of variables in there. And you deploy it. And there's a couple dozen different sort of repos like this. And it kind of gets overwhelming at times. But pretty much automated it all and integrated inline. So secure software factory is one of the main concerns you're going to have is identity access management, right? You'd be surprised how many organizations aren't really prepared to handle Active Directory or LDAP outside of node authentication, like outside of logging into a box. This is one of the reasons why I hate GitLab. They have 2 people across the entire world that is responsible for access, and I was telling them how broken their LDAP sync functions were. I should not be telling the vendor how to, I don't know. Anyway, it's really important. So if your organization does not have that properly set up, you're probably going to get side channel exploited through it, because a lot of these systems get very complicated. You can deploy GitLab. I've actually done that already. We're not going to do that anyway. But shared resources for this workshop, just so we've got a team there. It's got Eclipse Che in there, which is a cloud-based IDE, and a couple other little fun things, sample apps. CloudBeast Core. CloudBeast Core is just Enterprise Jenkins. It does some cool stuff to make it manageable across your enterprise. So if you are doing something more than just like a rinky-dinky little application on your laptop, you're going to need this. Sonar Cube. Again, some of that smell checking of your code. Sonatype Nexus. So that is going to proxy all your requests to your different NPM and Maven registries and all this other fun jazz. Sonatype IQ sets your policies, so if I don't want that beerware license, that's no problem. I'm going to set that there. Rocket Chat, because you need chat. I like it. Bastion Host, let's also throw that in there too. So it's a cool little sample wizard. I'm just going to throw some garbage values in here. And yep, that sounds good. Oh, that's autocomplete. I don't want y'all to see that. And apps. All right, we're gonna make 2 users. Password is that. That's actually our workshop password. It's going to provision namespaces. This little workshop resources, team resources thing is pretty cool because it actually provisions a bunch of resources. It provisions a bunch of roles. It sets a lot of security context. It sets permissions on what they can do and access. Because some of these tools do have root access to the cluster, which you're not really supposed to do. Don't say that. I try to practice what I preach, but it does a lot of cool stuff in the background. One little checkbox to enable LDAP. We'll throw in a little bit here. We're not going to use unsecure LDAP because that would be screaming my directory manager password across the internet and not pass. And the LDAP realm is, yep, why not? And we're going to do that and that too. All right, little demo app. We're going to secure routes with Edge TLS. I've got wildcard SSL throughout everything on my cluster. It's freaking beautiful. You know, even if you work with Let's Encrypt to do, you know, stateful app deployment with SSL, or if you manage your own certificate authority, it's still, this is really nice. Just a little checkbox. We're going to integrate that with LDAP too. A nice little checkbox. We can go through here, more checkboxes. Boom. Just kind of integrate this. So there are a couple little caveats. When you're deploying most LDAP services, Active Directory services, there is a certificate authority at the base of it. And a lot of those times that certificate authority is going to be self-signed because you're not going to set LDAP up or Active Directory with, you know, VeriSign or Komodo script or whatever, right? There are different sort of kind of CA authorizations. But in order to allow your self-signed certificate to get authorized, Java has a couple issues with it. I love Java. You have to basically rebuild your key store, and doing it on OpenShift, you can't do that with the system key store. So you have to copy it, you have to inject it, you have to reset the Java options to actually redeploy, because OpenShift does not allow root execution normally, unless you specifically set it to. So we're going to check a couple more boxes. We're going to secure everything. We're going to integrate everything with LDAP because, you know, why not? Bing, bang, boom. That also needs its own repo because that also is a Java application. Yay, why not? Java eats the world. This is not my origin. Yep. Oh. Yep. And not my pass. RCL. Not my pass. And we're just going to click next. Alright, we're going to ignore that because this is just my workshop deployer, so I don't have any customers looking at it. So I got to, this is like my Agile, I didn't give myself any real feedback here. But what should happen as soon as you click finish, yay, it still works. You get a nice little zip file, right? You got a deployer, you got a teardown script, because I'll tell you what, you've got 400 different namespaces and roles to remove. You don't want to do it through a CLI, like manually, or you don't want to do it through a web UI manually. That's going to suck. So that was very key when you're trying to deploy these containerized workloads. Figure out how to tear it down too, which usually involves a lot of labeling. Labeling and annotations in Kubernetes is very important and very useful. And we got a deployment script here. We're just going to run that with a little text there real quick. Of course it opens it on this screen. All right. So, hey, just a little bash script here. A bunch of little variables. You can switch them on and off afterwards. A couple checks. We're going to set a lot of OpenShift commands here. OpenShift, by the way, is, again, just Kubernetes. So OC commands basically are just kube control commands. Fun little fact. And we're going to do a bunch of stuff, right? I've already got where we're going. So all right, I know that looks super duper exciting, right? We're gonna let that just kind of roll for a minute because it is a pretty big little execution script, and we're gonna fly through the rest of this container security bit. All right. So while that is deploying, it's doing a bunch of fun stuff in the background. We're going to go in there. We're going to have to break it in order to actually deploy the rest of it in a minute. But otherwise, let's talk about container security, right? Container security is the fundamental part of what you need to do before you get to Kubernetes. Because guess what? There are more container exploits to escape a container context than there are to attack your Kubernetes API, okay? Fun thing to do with the Kubernetes API, if you get access to it, just DOS it. It'll kill itself. I've destroyed clusters by accident just telling it to do too much at once. It will DOS itself, basically. And if you got a large enough cluster, it'll do it very quickly. Either way, what are containers? Again, it depends on who you ask. Ops, that's like a tiny VM, right? You just get more little tiny VMs on it, and my developers, they think it looks like I put my application in there, I say I need Python 3 instead of 2, and then it's ready to rock and roll. Great. Now, it's not quite as simple as that in a secure context, okay? It actually gets pretty hard. So let's talk about the 10 layers of container security really, really quickly. This is the one red hat slide. Multi-tenancy, your host. Everything is abstracted from your Linux kernel. If your Linux kernel isn't that robust, then you're kind of, well, boned. Some of these constructs are not available in all Linux kernels and not available in all Linux operating systems. So if you're running RHEL, you're set. CentOS, you're set. Core OS, which is a specific type of container operating system based with OS tree that is immutable and more atomic. It doesn't really use normal Linux file systems. It's a bunch of weird stuff. But they are a little bit more secure. They do have a couple more functions to secure this bit. Otherwise, I've scrubbed out as much of their salesy shit as I could. Namespaces. Namespaces have actually been around Linux for a little while, but they haven't really been operationalized that easily, right? Namespaces contain pretty much everything that you have about a process or a series of processes. Okay, so again, we can put multiple containers in a pod. Okay. Now, SE Linux is something that's very important. How many of y'all still turn off SE Linux? Well, it's natural. Honestly, I do it a lot of times in my VMs just to keep moving along. But in a production system, you should learn how to make policies. I've got an SE Linux workshop. Happy to send you a link, help you out with that, whatever's clever. It's good. It makes it a lot simpler. But it's still SE Linux. It sucks. But it is very important. SE Linux at the core is just a labeling system. Everything on Linux is file, but SE Linux labels those files with who can use it, what it can do, where it can go, and all sorts of fun stuff, right? And this is kind of what one of those labels looks like. So if you give things the Z tag, like LS or PS, Z, big Z, it's going to give you the SE Linux context around that too. It's going to tell you the users what kind of runtimes it's bit. This is assigned as a container runtime, so we know it can execute container workloads. Great. Out of the box, we've got a little bit of an SE Linux policy base. Otherwise, some operating systems do not include that because, like, Ubuntu uses Apple Armor, so, ugh. Either way. As far as tagging things, again, SE Linux is just a labeling system. What we can also do is now tag things with container context. So what this little container context here lists is that hosts can be accessed by container 0 and 1, and secrets can be accessed by containers 0 and 1 as well. Any other container without those sort of contexts and IDs will not be able to access it. It also won't allow access to any other user in or outside of the container. So that's pretty nice too. And hey, you turned off SE Linux, you're vulnerable now. SE Linux has actually stopped a number of container exploits. There's been a number of run-C exploits that have allowed escaping containers very quickly from, web applications. It's been pretty scary. But otherwise, another really cool, useful function in the Linux system is C groups or container groups. Container groups basically just take your resources and put them together and give you an addressable way to interact with them, right? Setcops. This is, again, something kind of unique to what RHEL, CentOS have. This allows you to deny system calls, lower-level system calls to containers. Okay, so that's very useful in completely blacklisting network access. Now it is a way to remove and give privileges. So you can set specific always allow, you can set specific denies. All right. There are a couple of read-only mounts. They're traditionally read-only, but everybody thinks that, oh, I didn't assign my container volumes. Well, it has no access to my host file system. That's not true. A lot of ways to attach volumes after. It's really fun. Watch Ian Coldwater's talks. They've got some pretty interesting stuff. But also, think about where your sources come from, right? So where are your container images coming from? Are you just pulling your base images from Docker Hub? Like, it's not that hard to build a container. Look at the Docker files. I got a bunch online. Check it out. Super, like a dozen lines from scratch. Not that bad. Do it yourself, okay? If you are getting it from somewhere, you need to be able to get some health metrics about it because maybe there are some tolerable risks in that container. For the meantime, They're mitigatable with certain defenses, right? You get a little vision into that. And just run your own container registry, to be honest. We're finding that a lot of registries are kind of getting up and down. So what happens whenever you need to deploy a workload and you've got all your private registries in Docker Hub, and Docker Hub's down? On-site registries are beautiful. So restrict where your containers come from. Maybe you just don't want Docker Hub in your enterprise. That's a great idea. Okay, we're running on a registry. Let's just lock that down. What happens whenever you try to run an image anyway? We built an image here. We've tried to pull it in. Well, we get a 403 from the Kubernetes API. Again, it's just a REST API, so it's going to respond with an unauthorized. Pretty cool stuff. When you're thinking about building your containers, don't just build a container for this, and build a container for that, and build a container over here, build a container over there. Build them in layers, which is really a powerful tool. So that lets pretty much everyone get into this DevOps lifecycle, which is very useful for cultural enablement, right? Some operations folk are like, I'm not going to deal with all this. Like, the developers are going to give me a container, I'm just throw it at like Docker Swarm or whatever. And I'm like, yeah, that's great. So you can do that and forget about it, or you can use these tools yourself and upskill to an SRE role, which is really nice nowadays. But they're going to build some container images, your base secure. Think of it as your golden image, right? We got that sitting around. We've got that from our VMs. Then we're going to make sure that everything in between is available. So I'm going to give you a Python 2 version and a Python 3 version and this, that, and the other, and give you a couple other little middleware layers, and your applications kind of rest on top. But what's cool about that is that if there is vulnerability in that middleware layer, like say there's a little Java vulnerability, heavens forbid, we can swap that out from all the containers that's built upon. All the applications that are built upon that layer, we can swap it out. We don't have to touch that base container image because, again, these are just tar files built on top of each other, all right?
Did you mention a particular tool to build containers in layers?
Pretty much all of the container building runtimes will do it in layers. So basically what happens in like a Docker file can be run on a bunch of different runtimes. What happens is you got a bunch of different tasks. You can add files, you can copy files, you can run commands after it exits, set the entry point. One of the major tasks you can do is just run a series of shell commands, right? So what's very common is copy file over, like copy my shell script over. Then your next command is run shell scripts, right? So that's a very common thing that we see in container builds. What the container build time, the container builder runtime will do is that it'll take that base image, like say we based it off of Ubuntu, or we based it off the universal, base image, whatever you want to do. It'll pull that in, that's your first layer. Your add command is your second layer. Your run command is your third layer. If you have any other subsequent initial commands afterwards, it's going to add that as another layer, which is really cool, right? So let's say I'm developing a container, and starting from top to bottom, it fails on the 8th out of 9th step. Okay, pretty common as well. For the first 7 steps, those layers were already built. It knows well enough because it's that atomacy gives you that benefit of going, okay, I've already done this. Let's just do this last bit. And you're just trying to get past that wall until your container finally builds. It's pretty cool. That layer aspect kind of gives you some really rapid development practices. Good question. SEC, secure context constraints, also something kind of unique in their little flavor of the kernel. What this allows you to do is basically just kind of gate where things are. So what this allows, for instance, in the OpenShift cluster is, on a Kubernetes cluster, you're running everything as root traditionally. Ugh. Ooh, yeah, that's great. In OpenShift, there's an SEC applied that does not allow anything to run as root by anyone. Even if I'm the cluster administrator, I cannot run something as root unless, as cluster administrator, say I can run something as root in this namespace. Container deployment permissions, that's also important. Sometimes you don't want to allow people to deploy, you just want people to consume, so roles, pretty nice. Let's also scan these containers because after we've built them, let's make sure that there's nothing hokey in them. So we actually take some of those OpenSCAP scans, Ansible lockdown, and actually point them at a container image and scan it just like another Linux system. pretty cool stuff. So especially if you're trying to get like stigged containers, which is, anyway, this is kind of useful to kind of get you there. Authorization, again, identity access management, LDAP is something a lot of organizations struggle with past nodes. How do you use that in a namespace context? How do you use that in a container context? Like attaching a realm to a container is actually pretty difficult, but it's not impossible. And if you're not comfortable with certificate authorities and running your own and public key infrastructure, you've got to, because guess what? The heart of all of these nodes is SSL encryption between all their communication. Now, what's funny is I've seen a lot of these proof of concept clusters that are just quickly sprayed out into some infrastructure. A year after it's deployed, start to fail. They're looking at it's like, why can I not access anything in my cluster? My workloads are still going, but I can't access my Kubernetes API. The answer is your certificate authority that's expired. It's great. So you need to learn how to manage keys. Isolating workloads with containers. Kubernetes is just going to put it wherever it can put it, right? What if you don't want it to put it wherever it can put it? A lot of people don't want to. Maybe you want it to run on a specific kind of hardware. Maybe you're allocated some specific resources. Not too hard. What about on a network side? Well, that depends on what sort of networking layer you add. There's Open vSwitch, there's Weave, there's Flannel, there's a couple other additional service mesh add-ins that add extra functionality to this as well. It depends on what you do pick, but important to note that if you are running multiple users within a similar cluster base, you need something that does support multi-tenancy. And just like all of our other YAML, we can define network policy. So this is interesting. Network policy, you might have seen kinds like pods, routes, services, those are all just custom resources, right? You don't get that in normal Kubernetes clusters either. You need a custom resource definition to kind of lock down that policy with your networking layer. Now your ingress and egress, your load balancer, say I don't want anything to hit my master nodes, even if they're accessible in a private or a public region. You can actually lock it down to where the cluster knows of your load balancers so that no other communication will occur. It's really nice for your main entry point to your API. Again, everything between the nodes is encrypted with IPsec, but you can extend that out with additional network infrastructure if you want to overlay additional connections and bridges. Your storage layer, there's a way to attach storage after the containers run. There's ways to attach other people's storage after your containers run, which is really fun too. There's ways to basically tell Kubernetes, hey, stop this pod real quick, and it will. But because it's deployment configuration, replica set, whatever you have it set up in a stateful set, however you've got it, it'll just redeploy, right? But between that and its termination, you just attach its persistent volume. Persistent volumes, real kludgy systems, you've got storage classes. So I've got GP2 for EBS on Amazon. Then you can have like an NFS storage class. But you're going to have these storage classes, you're going to have a persistent volume, and you're going to provision that for your users. Like I'm going to be like, here's 10 gigs to use for whatever you've got. Then we're going to claim X amount of those gigs that I've got. And then as soon as we've got that, we can attach it to an actual pod. And that way, your pod and container can actually have persistent storage, because otherwise these are ephemeral beings. As soon as you make a change to the file system and turn off that pod in the container, it's gone. So people think that storage is pretty hard in container. It's not, but doing it securely kind of is. API management with a lot of different things. You're deploying microservices now. JWT, here, there, and everywhere. Well, you need to learn how to manage that coming in and out of your services and in and out of your routing stations. There are a bunch of different sort of API gateways. Honestly, you can use Nginx. It's pretty cool. And we have gotten really used to being able to deploy clusters of cloud resources here, there, and everywhere. If I want something in the APAC region, and if I want some VMs in Ireland, I can do that right now. And I know how to manage that. But how do you manage container workloads in a multi-region fashion? How do you share resources? How do you share secrets? Right? How do you share communication between? Because Kubernetes is keeping log of everything going on in that cluster with something called etcd. It's just a key value store, which just ensures a state. If you've got a long time delay between your communication points and your API requests, you're going to have a bad time. You're going to have some split brain issues. I know what you think. I said 10 layers of container security. They're like 80 that you saw. Well, it gets even deeper than that. And that's just on the container side, and that's usually on the orchestration side. There's still a little bit more kind of goes into the application layer as well. So this is where kind of security kind of starts to fall in, right? We're usually just throwing things over the wall. Something just tells us to stop and do not go. And in a DevOps environment with containers, once you have insecure containers, you start to have to figure out how to run it after you've built your workloads and you've delivered your application is a hard conversation to have. So we have to encompass security, right? I'm going to kind of skip ahead a little bit of this just because running out of time, evidently. But a couple of takeaways from here as far as building software, developing containers, deploying them and all. So that's kind of complicated. I told you yesterday you want to push the easy button. OpenShift actually kind of does a lot of those 18 layers for you.
What does?
OpenShift, Origin. There are a couple other container run platforms out there, like Pivotal's got one. What's funny about Docker Enterprise just ships Kubernetes. They don't even use Docker Swarm anymore. Remember yesterday I said standardize? Everyone has standardized on Kubernetes, pretty much. There were a couple other container runtime environments that have come and gone, but everybody's like, yeah, this just makes sense, kind of, maybe, at a certain point. So push that easy button if you can. If you want to get started on your laptop, check out Minishift. Minishift is a great way to kind of get started with those workloads. Not everything should be in a container. Some little fun thing, you got to figure out what workloads you want to put in your container. All right? Some people are like, I can't put an Oracle database in a container because storage and all that fun stuff. It's like, yeah, you could, but you don't really want to. But what you should also scope out is how some of these underlying systems work, like OpenSSH. Some people are like, I told you yesterday, you're not SSHing in those containers anymore. That's just, you're just going to rebuild them better than ever before. But there have been people who try to put SSH into a container. You can do that, but the issue with that is that OpenSSH requires root level access to some systems to spawn up new TTY devices, right? So in order to run OpenSSH in a container in a secure context, OpenShift, you need to break it and allow root access. So you just provision your users an application, a web SSH terminal, OpenSSH endpoint, whatever, running root on your cluster. All right, and that's kind of like giving you keys to vCenter or vSphere, whatever it is now. All right, I can do everything because now that I have root on one of our nodes, and I'm in a gang. I'm an application node. Hey, we traded SSL certificates. Like, you know me. You know me. Why don't you just turn everything off and run some of these crypto miners? You want to do that? You want to do that? Hey, Tesla? Hey? But anyway, if that does happen, you need a way to find out about it. Kubernetes normally does not come with metrics logging. You're probably going to want to learn how to use something like Elastic. Elastic's really cool. The Elk stack, check it out. Very fast stuff too. But otherwise, think about where your sources are coming from. Where are your dependencies for your containers coming from? If you're not building your own, it's easy. But also for your applications, right? There are a lot of ways to kind of spike the punch as far as open source dependencies come, and we've seen that a couple of times already. But anywho, To wrap things up, right on the buzzer bell. Questions, comments, concerns?
You said SRE earlier, a really good thing.
Yeah.
What is SRE?
So an SRE is a site reliability engineer. Ooh,
Gotcha.
it's one of them fancy, newer terms as of the last couple of years, right? That is big cane stuff right there.
I thought you mentioned it as some kind of a developer status account, something.
No, maybe SCCs, security
Okay.
constraints, but SREs are what ops are going to become. If you use these automation practices, if you learn how to build your base containers, if you embed yourself with these new practices, right? If you go, I don't need to learn this, I don't need to do this, it's not my concern, in a couple of years you're going to find out that pretty much everyone is doing this. From data scientists, I've got data scientists doing GitOps with Hadoop clusters. Like, that's weird. But everyone is doing this sort of development lifecycle, this software development lifecycle. The supply chain is extremely important. So, but either way, the site reliability engineers, if you adopt these automation practices and these containerized workloads and know how to run Kubernetes and know how to access the metrics and the logs and get the visibility from what's going on site, you become the site reliability engineer, where you are omniscient, know everything that's going on through your enterprise. And you know exactly what happens whenever one of these pods starts acting up. Very important role, because a single runaway workload can actually ruin your entire Kubernetes infrastructure and cluster. So site reliability engineers are very important.
You mentioned tutorials available. Where are they?
Yeah, they are on, let's see here. So if you go to fiercesw.network, that is a quick and easy way to get to it. Got a couple things here. You got a couple of my presentations. If you want to check out some other weird stuff I've done. The GitHub from our main GitHub, that's, I don't know what to call it. That's downstream. I'm upstream. Cool stuff's in my repos. I haven't really synced it yet. I'm not good at syncing, unless it's production stuff. I'm gonna start. I want to check that out. Teleprompter. We use that for some of our little video productions. That's open source. Check it out too. Workshops though. All right, and we've got. There we go. We got a couple up here. We've got another one coming up here soon. The Cloudera ones, you've got your Data Science 101 and 102 and some fun stuff. Those are big boys. I can't deploy that today. But otherwise, here are a couple other kind of Red Hat centric ones. We have a larger list.
Is there a list of free containers that someone can play with to dork around with this a bit, see what's going on?
What do you mean free containers?
Well, I mean, you have like images or something, Docker containers?
Yeah. On my Docker Hub, profile, you've got a bunch. I've got a bunch of resources up there to check out. Pretty much all of them are pulled in from my GitHub as well.
Okay.
Outside of that, there are a bunch of different registries to check out. Docker Hub has, I think, like 3 billion different images on there. There's a lot to start off, and I've got a lot of resources for you too. I'll probably be sitting out there to finish this deployment that I didn't get to finish. Just to finish setting up the software factory. If anyone wants to see me break CSRF validation in order to deploy this, which is asinine to have to do, but I can show you that. I can give you some extra resources on some of those free potato stuff.
You said Ansible Enterprise earlier. Is that the same thing as Ansible Tower?
So, man, I love these naming conventions. So, Ansible Enterprise, like, there's the runtime, the CLI, and then there's Tower, right? So, Ansible Enterprise right now is both of them is what they're offering, is the enterprise version. tower, the community version is called AWX. It's free, it's upstream, check it out, just like the normal community version of Ansible Tower. If you guys are interested in Ansible, I could be more than happy to deploy a little workshop. Got a couple different ones up here and run you through a couple little quick gigs. Yes, sir.
Do you have a good system library scanner? Originally, we were using Black Duck, but their pricing structure was so insane that we ran away screaming.
Yeah. I mean, what kind of metrics are you trying? What workloads and what kind of metrics? Well, let's chat out here. Alrighty, guys. Thank you for your questions, attention, all this fun jazz, and for your patience as well.